Standing waves, also known as stationary waves, are fascinating wave patterns that appear to vibrate in place rather than traveling through space. These special patterns form when two waves of the same frequency and amplitude travel in opposite directions and interfere with each other. Unlike regular waves that move from one point to another, standing waves create a pattern that remains fixed in position, making them appear as if they are standing still. Standing waves are created through a principle called superposition, where two identical waves traveling in opposite directions combine and interfere with each other. The most common way this happens is when a wave reflects from a boundary and travels back, interfering with the incoming wave. The resultant wave pattern can be described mathematically as y equals 2 a sine k x cosine omega t, where the spatial and temporal components are separated, creating the characteristic standing pattern. Every standing wave contains two critical features, nodes and antinodes. Nodes are points where destructive interference occurs, resulting in zero amplitude and no displacement whatsoever. These points remain completely still. In contrast, antinodes are points where constructive interference occurs, producing maximum amplitude and displacement. At these locations, the medium oscillates with the greatest energy. Nodes and antinodes alternate along the standing wave pattern. The spacing between nodes and antinodes follows precise mathematical relationships. The distance between two consecutive nodes is always lambda over 2, where lambda represents the wavelength. Similarly, the distance between two consecutive antinodes is also lambda over 2. However, the distance between a node and its adjacent antinode is lambda over 4. This regular spacing creates the characteristic repeating pattern of standing waves, with nodes and antinodes alternating throughout the medium. The behavior of standing waves depends heavily on boundary conditions. At a fixed end, such as a string attached to a wall, the wave reflects with a phase reversal of 180 degrees. This causes a node to form at the fixed boundary. Conversely, at a free end where the medium can move freely, the wave reflects without any phase change, resulting in an antinode forming at that boundary. These boundary conditions determine the allowed patterns that can exist in the medium. When a string is fixed at both ends, only certain wave patterns called harmonics can exist. The first harmonic, also known as the fundamental frequency, occurs when the string length equals lambda over 2, creating just one antinode. The second harmonic has the string length equal to lambda, producing two antinodes. The third harmonic gives us 3 lambda over 2 with 3 antinodes. In general, the nth harmonic follows the pattern where L equals n lambda over 2, creating n antinodes along the string. The frequencies of standing waves follow elegant mathematical relationships. The fundamental frequency, or first harmonic, is given by F1 equals v over 2L, where v is the wave velocity and L is the length of the medium. For any nth harmonic, the frequency is simply n times the fundamental frequency. Expressed as Fn equals nv over 2, L, this means all harmonic frequencies are integer multiples of the fundamental frequency, creating a harmonic series that determines the characteristic sound of musical instruments. Standing waves have several distinctive characteristics that set them apart from traveling waves. First, there is no energy transfer along the medium, as the energy remains trapped within the standing pattern. Second, the wave pattern remains stationary in space, never moving from one location to another. Third, the amplitude varies continuously from 0 at the nodes to maximum at the antinodes. Finally, all particles between adjacent nodes oscillate in phase with each other, meaning they reach their maximum displacement at the same time, though with different amplitudes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.